Hi everybody, my name is Jacob DeLoa. I'm an electrical engineering student at SDSU. I'm doing an update/progress video for our senior design group. Our team is 49 GAPS, stands for Garage Assisted Parking System. That's our project, so here we go. Okay, so we're back. This is the project basically. We have the garage and a couple different separate modules of what we've been working on. The garage itself has a door where you can pull it up and down. With it's supposed to be a pulley system, but we have not yet connected the motor. Something that we're going to troubleshoot in the future, but for now let's just stick to the first module. It's a 5-volt stepper motor connected to an Arduino Uno microcontroller. There's a physical push button and a motor driver, and basically we get it to rotate both clockwise and counterclockwise with the push of a button, and we're able to stop it at any time. So let's just go ahead and display that real quick. So it's moving clockwise, it'll stop and a delay, and then it'll reverse the other way. And it goes for 1.5 revolutions, which is basically how much it takes for the bottom of the garage door to reach the top and then back down. Alright, so it looks like that's finished. So basically we have that first part done with the physical push button. We're going to move over here. And this is a very similar setup. The only difference here is that it's working through Wi-Fi. So we're using an app and a digital button to turn the motor instead of a physical push button. We have a different controller in there, a different microcontroller in there. This is a micro, not an Uno. So it's a little bit smaller, but we're taking 5 volts to step down with a buck converter, this little buck converter. It steps down to 3.3 volts to power the Wi-Fi chip. And the little button in there is not the physical button to control the states. It's a reset button for the Wi-Fi chip. And the motor itself right now is being driven by an external battery source, which is 4 AA batteries. It's about 6 volts. We're going to try and look to that in the future because we're not sure if we're overdriving it. Right now we've been either overdriving it or underdriving it. Because you'll notice in the video right now when I show you how the button works. So we go in the Blynk App, we open it up, we have our little digital button. Alright, we're going to turn it, make sure that we're pinging. Let's go back, we're offline right now, so let's go back to the code. We can pause it. Okay, so we're back, and we had a little problem with connecting to the Wi-Fi, but now we have it pinging. You can see it here. We've connected it. All right, we're ready to ping 13 milliseconds. We have the Blynk app. So let's go over and look at the circuit real quick. All right, so if we hit this button, the motor should turn on. Let's try it again. There it is. So there's some delay. But again, we're going a lot slower compared to the physical button, and we think it's because of current. Still troubleshooting, so it's going to be a little bit to figure it out, but we're going to do the external power supply, an adjustable one so it can draw as much current it needs. So it's going to keep going around. It's going to do the 1.5 revolutions, the same as this one, and then it's going to stop for, I think we have a certain amount of time on it. And then it goes back in the other direction. So right now it looks like it's going clockwise, but it's actually counterclockwise. That's pulling up the door. And then it'll stop, and then it'll come back the other way. Look like it's going counterclockwise from this angle, but if we flip it and we put it on the door, it'll be going clockwise, pulling down the door. Alright. We'll wait till it finishes. There we go. Alright, so we finished. Let's go to the parking sensor now. So we're going to take the RC card. You want to go around? Yeah. Alright, so now we have the third module, which is the parking system, which is basically an ultrasonic sensor an Arduino Nano microcontroller, an LCD screen, an alarm/buzzer, and a couple of LEDs and a couple of resistors. So basically, the car will drive into the garage, and the sensor will send a signal, and it'll bounce off the car and be received back by the sensor. And basically, in the code, we have it so that way, as the car pulls in and it's calculating the distance, LEDs light up at a certain distance, letting the driver know to pull forward or to slow down and to stop the vehicle. And then also the buzzer will pulse that different sounds at specific distances to the same distances that the LEDs turn. And then the distances also can be shown on the LCD screen. You can kind of see them there a little bit. So it's at 37 centimeters right now. So in the code we have 37 centimeters, not light up any LED and not turn on the alarm.
Yeah.
So we're going to pull in the car into the garage right now. Let's pull it in forward. So the LED turns green and then the buzzer starts making a sound. I'm going to pull it a little bit closer. Yellow just turned on and a different sound. Let's see him try and trigger red. Red didn't trigger, so let's try it back and out. And we'll readjust. There's red. So red is really kind of picky because it comes in at where the sensor is the closest. So sometimes the bounce could, as the signal gets sent out, it could miss because the signals go out in kind of like a cone shape. So let's hit, I hit it, sorry. Back it up, go yellow, back to green. Alright, let me pause it. Alright, so that's basically the project so far. We've come a long way. We have a couple of modules. We have a whole garage set up. We have the RC car. And we encountered some issues here and there. A big one is the amount of current on the Wi-Fi module because of the motor and then the Wi-Fi chip. So the plan is to, again, try and troubleshoot by installing an external supply to drive the motor separately outside of the microcontroller. So another thing that we plan on doing is condensing the modules onto perf boards, soldered breadboards basically, because these are solderless, and as you can see, jumper wires everywhere. It's kind of messy, so we want to clean it up a little bit by soldering wires and making it a little bit more neat and organized and condensed. And yeah. Alright, that's about it. Thanks for watching, and we'll let some of the team members address themselves and who they are and what they contribute to the project in a little bit. Alright, thanks everybody.